Okay, 6.4 is the triangle midsegment theorem. Okay, a midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. Okay, so kind of some notes here about the midsegment. We know that every triangle has 3 midsegments. Okay, and you can see them here. And those midsegments, they form the midsegment triangle. Okay, you can see that they connect and all make a triangle. So they form a midsegment triangle. Okay, so in example 1, it says in triangle JKL, show that midsegment segment MN is parallel to segment JL and that MN is 1/2 of JL. Okay, so we have step 1 here is going to be the midpoint of JK and segment KL. Okay, and so M is going to be -6 plus -2 divided by 2 and 1 plus 5 divided by 2. Okay, and that would be the midpoint M is at -4, 3, which I can see here, -4, +3 is M, good to go there. N is going to be -2 plus 2 divided by 2 and 5 minus 1 divided by 2. And that leaves us with N at 0, 2. Okay, the next thing that we want to do is find the slopes of segment MN and segment JL. Okay, the slope of MN is 2 minus 3 on top over 0 minus -4 becomes +4. So that's -1/4. And now the slope of JL is -1 minus 1 over 2 minus -6 becomes +6. So that's -2/8, which is the same as -1/4. So we know that MN is parallel to JL from that part right there. Okay, so then we have step 3, we're going to compare lengths. Okay, and so we have from M to N, distance formula is going to be 0 minus -4 becomes +4 squared plus 2 minus 3 squared is equal to 16 plus 1, which is the square root of 17. Okay, and then let's leave it there for right now. JL is the distance formula, square root of 2 minus -6 becomes +6 plus -1 minus 1 squared. And that becomes 64 plus 4, which is the square root of 68. 68 we know can be broken down into 2 and 34. 34. And 34 can be broken down into 2 and 17. So this is actually 2√17. So then if I look, the square root of 17 is equal to 1/2 of 2√17. That is true because the 1/2 and the 2 cancel and I get square root of 17 is equal to square root of 17. So we know that MN is actually 1/2 of JL. Okay, all right, theorem 6.8 goes on to show this relationship. So underneath here I have that DE is equal to 1/2 of AC. And the midsegment theorem in words then says that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. Okay, so I need to actually go over here and add that DE is parallel to AC. Okay, all right. So then looking at example 3, it says triangles are used for strength in roof trusses. In the diagram, segment UV and segment VW are mid-segments of triangle RST. Find UV and RS. So I know that UV is going to be 1/2 of RT. So that would be 1/2 of 90, which is 45. And then RS, okay, R to S, I know is equal to 2 times BW right here, okay, because that's its mid-segment. So 2 times BW, which would be 2 times 57, and that's 114. Okay, so there are your 2 answers for example 3. Okay, and that is actually all of the notes that you need for this section. So let me know if you have any questions.